Hi, today we're going to be going through some of the things that you learned in algebra. You may have been in geometry for years. This will be a little refresher course of what you should know. We're going to be starting out with sets of numbers and classifying numbers according to what sets they belong. The first set we're going to talk about is the natural numbers. Sometimes these are called counting numbers. That's because these are the numbers that you can count. These are like the numbers 1, 2, 3, 4, 5, 6. You know the drill. All those numbers. All right, so that's one set of numbers. The next set that we're going to talk about includes all of those numbers and also the number 0. So it's like 0, 1, 2, 3, etc. So that one includes the idea of nothing as a number, 0 as a number, and those are called whole numbers. All right, so the next set is going to include all of the natural numbers, all of the whole numbers, and also will now include the negative numbers. So like ... -3, -2, -1, 0, 1, 2, 3, in all directions. And those are called integers. So whole numbers are integers, but not all of the integers, like -3, is not a whole number. So all the whole numbers are integers, but not necessarily all the integers are whole numbers. Okay, another one that we'll add into here. Put another circle piece for it. These are the rational numbers. Now, rational numbers are anything that could be a fraction. So like, let's say 0.5 will be in here, because 0.5 is the same thing as 1/2. Or 8/3 could possibly be in here. What else? Let's see. Something like 0.3, because 0.3 would actually be 3/10. Okay, so you have to actually check on this one to make sure that the decimal could become a fraction. And these ones are called rational numbers. All right, and that includes, rational numbers includes all the integers. So like 0/0, well, 0/1 is a rational number, or 1/1, or 2/1. So integers, those are all rational. Whole numbers are all rational. Natural numbers are all rational, so it includes all those. That's why I put the circle like this. Now I'm going to put one where it doesn't include. So it'll get its own little circle out here. And in its own little circle, these are going to be all of the numbers that can't become fractions. So what do those look like? Well, you know one number that you worked with a lot in geometry last year. That's the number pi. And pi is actually like 3.14159 ... It goes on forever. That can't be made into a fraction, and so it's not rational. So this one is called irrational, which basically means not rational. So pi is one of those, like the square root of 3. Okay, if you put that one into your calculator, and I'll show you how to do that now. Turn your calculator on, My calculator has the little yellow square root right there, so I'm going to press second, the square root button, and then put 3, finish up the parentheses, and press enter. And that'll turn that into a decimal for me. And notice how this decimal goes on forever and it doesn't repeat itself. Some of them can go on forever and repeat themselves, like 1/3 is actually 0.333333333333333, but it repeats itself, so that's a little bit different. It's when the decimals go on forever and they keep changing numbers, and those are irrational. Okay, so notice that it's in that circle by itself. It means, you know, natural numbers can't be irrational. They have to be rational. So it's off by itself. And then all of these together, every single one of these are circled all together. All numbers that you've used so far are real numbers. And this year we'll actually be learning about what's not a real number. But for now, every number you've ever seen has been a real number. Okay, so those are all the different sets that we could go through. We'll also be revisiting how to do a number line. So, to draw a number line, you start with a line, and then often I'll put 0 in the middle. And then you have to count off by something. You can count off by 1s, you can count off by 2s, 3s, 5s, 10s, hundreds. As long as you're always counting off by the same thing for each little tick mark, you're good. I'm going to choose 1, 2, 3, and then this would be -1, -2, -3. And I'll put little arrows here to indicate that this goes off forever in either direction. Now I'm going to give some numbers. Like we'll say -3/2, 1.7 bar. Remember that little bar means forever. So it means like 0.7777777. And we'll do square root of 5. Okay? Now, it'd be really hard for me to figure out how to graph all these different things in different forms. Like 3/2, it could be in a decimal form. Normally, I like to change everything to decimal form because that's the easiest to do. Remember, to change a fraction to a decimal, you divide the top number by the bottom number. So if I divide 3 divided by 2, I get 1.5. And so -3/2 is -1.5. Those are the same thing. And then this one I know is 1.777777. And then in my calculator, I'll do that square root thing again. Square root of 5. This is 2.236. And it keeps on going, but that's where I'm going to stop it. Okay, so now I can put these on there, right? So -1.5. Well, that's in between -1 and -2. So I'll put a dot there. And I won't put -1.5. I'm going to put the original thing above it, the original mark. So this is -3/2 is right there. The next one, 1.7 forever. So that's between 1 and 2, and it's closer to 2. So somewhere like here. And I would put 1.7 bar above that. And then square root of 5, 2.236, that is between 2 and 3, but is closer to 2. So that goes here. And instead of putting 2.236, I'm going to put square root of 5 as the label above that. So that's just a little reminder on how to do number lines. And this can really help you when you're ordering real numbers. Say we have something like compare negative square root of 0.25 and the negative square root of 0.0 0, 1. All right, well, I don't really know what those things are until I actually take the square root of them. So in your calculator, you would go ahead and take the square root of those things. So here we go. Square root of 0.25 is 0.5. Okay, so this is actually negative 0.5. And then the square root of 0.01 is actually negative 0.1. All right, so if we're talking about a number line with these, we'll put 0 here, negative 1, 1. All right. Well, where would negative 0.1 go? Well, negative 0.1 is like really close to 0, right? It's like here, negative 0.1. And then where would negative 0.5 go? Well, it's exactly in the middle, halfway between 0 and negative 1. So which one of those is bigger? Well, always the one on the right is bigger. So that means negative 0.1 is bigger than negative 0.5. So negative 0.1 is bigger than negative 0.5. And if I put my originals back in there, this means that negative square root of 0.01 is greater than negative square root of 0.25. And so this would be my answer, this greater than symbol. Okay, so I'd like you to do one of these on your own. Let's see here. Negative square root of 0.08 compared with negative square root of 0.1. All right, pause the video and see if you can do that one on your own. All right, I'm going to do it now. So I'm going to actually take my square root of 0.08, and I get, this is like 0.2828, and that's negative. And then this one, the square root of 0.1 is 0.316, negative. And so which one of those is bigger? Well, since they're negative, this one is actually on the right, so this one is bigger, so I'll use this greater than symbol. Okay, so you can see how this works, and when we get to the assignment, you can just put those right into the computer with that symbol. Okay,